I've just started making a Nixie tube clock, which came from website Etsy, ETSY. You can Google it. And this is a kit that's made in the Ukraine. And it comes in this really nice wooden box, as you can see. I've actually taken most of the parts out, but these are the actual Nixie tubes. They're the IN-12 type, and there's 4 tubes altogether. As you can see, 4 tubes, and comes with a power adapter, which looks quite nice quality adapter. It is delivering 12 volts at half an amp, 500 milliamps. You can see there, and there you go. And so that's what will power it eventually. You'll notice that the end's been cut off, so it was obviously designed for, I don't know, it could have been a USB device or something like that. And they supply that jack connector, so obviously I have to solder that up, and for the actual device when I actually get that far. So there you go, there's 4 Nixie tubes, power adapter, everything comes in this really solid wooden box, which you can keep and use for something else. I certainly will. That's a nice bit of kit on its own. There's 2 main boards. There you go, AmberNixieLight. Actually, you can choose different coloured LEDs for the backlight for the Nixies, and you can probably see on there that it comes from or the email address is blackalex_2k@mail.ru. So if you want to contact Alex, you can do, to find out a bit more about the kit. And you can see on there I've actually installed quite a few of the resistors already, and a few capacitors. There's a lot of surface mount components on this. Now, I'm not great at soldering surface mount components. I can generally get away with it, but there you go. That's the one of the boards that I've started to populate with components already. Give you an idea of what you're actually dealing with. These are I say instructions. Basically, what you've got here is, if I got that the right way up, that's more like it, I think. But you can see here that you've got images. Let's start with this one. Images of the boards, and I'm starting work on this top row at the moment. And as you can see, as I've been going through each component, I've struck them off as I've completed them. I've struck them off on the diagram of the circuit board as I go along, and also I have struck them off on this other sheet which is provided, which is a list of components and their values. You can see here that I've started to strike off the resistors, so I know exactly where I am with installing the components, and if there's anything missing, then I can easily detect what that is. And there's a full circuit diagram of the Nixie clock on the back of the component list, and there's some further information here about how to set the device, or set the clock when it's completed, but obviously we're a good way away from that. All the components are provided in plastic bags, little plastic bags, and this is a typical one here. We've got a couple of, I'm not sure what they are, but you can see here that there's a component, or a couple of components. Oh, diodes. Okay, so there you go, a couple of diodes, D1 and D2. So you can go to your diagram, find out where D1 and D2 are, and I have to admit I haven't got that far with this. I certainly haven't been looking to install diodes just yet, but D1 and D2 will be somewhere, perhaps they're on the other side, I don't know, I'll find them soon. But the point is that once you've found your component on the on this list, you can cross it off there, and you can also cross it off this list as a double check. You've got some ICs, and you can see. So I'm going to improve the lighting a little bit here. You can see a bag of components, ICs there. There's what, 1, 2, 3, 4, 5 surface mount ICs, and 1 socketed IC complete with a socket. Rest of the components pretty similar. Setup, you've got an IC there, very dinky one. Again, that's going to be surface mount with the part number and where that particular IC will go. That one's IC6, so that'll be on the diagram somewhere when we get to that. And there's also some very tiny LEDs, which will be the backlights, I'm sure, and I think there's also some resistors in there as well. Yes, there are. Those are probably to go with the it's probably a resistor for each LED, I would have thought. But yeah, there you go, resistors and LEDs. And then you've got a bunch of peripheral components. I'll bring those into shot. You've got I think that's the backup battery. Pretty sure that's the backup battery. You've got what's the value of this? 16 volt, 220 microfarad electrolytic cap. Not sure what that is. I'm not great at my electronic components, so I have to admit, I'm sure somebody here will work out. You've also got these connectors which go like that, and what they will do is they will connect, once completed, these two boards together, so you can see here and here, and they'll get sandwiched together via these two connectors, one there and one there. And we've got some momentary switch buttons, a couple of those, I think. Yep, that'll be the power jack for that power supply set I showed you earlier. And what's that, a voltage regulator or something? I don't know what that is. An amplifier, I don't know, as I say, not hugely hot on all my components. A couple of electrolytic caps here. That's 220 at 16 volts, microfarad that is, and so is this one, I think, 220, 16 volts. So that basically is the entire kit. And like I say, there are a whole bunch more resistors. I've actually populated quite a few of these guys already, but it's very slow going because they are surface mount, and it's just me, a soldering iron, and an awful lot of patience. So what I'm going to do is going to carry on populating the resistors, because there's still a fair few to go yet. There's also, what I think in there is an absolutely minute, I don't know whether this will focus or not, an absolutely minute trimmer pot, I think that's what that is. For what, I don't know. We've yet to discover that. But there you go, tiny little trimmer pot. That was in with the resistors, which kind of makes sense. So I'm going to carry on populating all of those. Now, if you're not sort of hot on understanding how to install SMD components, I'm certainly no expert, so I'd recommend that you go and have a look on YouTube and just search for installing SMD components, and you'll find lots of people do it. Dave Jones at EEV blog has a video on that, which is very good. But basically, what I do is that if I'm going to be installing, I'm not too sure. Let's say there's a couple of capacitors there and one there. It might be a resistor, so I'm looking at the diagram. But what I would do is I would put a blob of solder on that. I'd then, using tweezers, and Lord knows you need tweezers for these tiny components, I would then hold the component up to the blob of solder. With the other hand, I bring in my soldering iron. A quick dab of the soldering iron will almost instantly melt the solder, and at the same time you just gently push the device into the solder and the solder will capture it. If the device is slightly lifted away from the board when that happens, then you just hold your tweezers on top of the device. Again, bring your soldering iron in, quick dab on the soldering iron, and the device will push nice and neatly against the flat of the circuit board. And then once that one side of the device is soldered in, then it's just a quick dab of solder and the heat on the other side, and it's installed. And like I say, if you look very carefully, yeah, it's not pretty. You can see here that one is not very square on, and you know, the amount of solder is a bit erratic. However, I'm hoping it will work. The most important thing I do is use a magnifying glass to check for any solder bridges, because the real fun comes in with soldering the ICs, and I don't know, we'll have a look at that a little bit more perhaps later on in the video. But there you go. I thought I'd first of all start off by showing you what I've got and how far I've got with this. And what I'm going to do, like I say, I'm going to follow these instructions. I'm going to hook out all the resistors and get the resistors installed. Incidentally, if your eyesight's not great, you like mine, get yourself a magnifying glass, because one of the things you will want to know is the value of components. You can see there that component is valued at 152. That is a resistor. Look at the components list, and just let me find where 152 is marked on this list. I'm not going to find it now, am I? But you know, so for example, here I've got I had a load of 103 resistors, which are 10k resistors, and the actual resistor is marked 103, and you can see on the board there was quite a few 103s. There you go, 103, 103, all the way along there. There's a 472 there, which is 47.2k. And that's the way to help identify what component goes in what slot. When it comes to resistors, it doesn't matter what the polarity is. You can put them out either way. Just for uniformity, I like to put all the resistors in with the writing in the same direction. But you know, that's just me. But when it comes to things like electrolytic capacitors, these do have a polarity. They have a plus and a minus. So there's the minus. So the other side will be the plus. So that will be your negative pin there. And you can see that there is a longer pin and a short pin. The longer pin is always the positive, and the short pin is the negative. And you can confirm that with the negative symbol on the side of the cap. So they are polarity critical, and as are these caps as well. Again, you've got the negative on that side, and the positive is the longer pin. And when it comes to looking at the circuit diagram, you can see here that you've got a capacitor C10. I don't know which capacitor that is. I'd have to look up which one that one is on the components list here. But importantly, you can see which side is positive and which side, therefore, by definition, is negative. And usually the negative has got a bar like that one to show which way the polarity is of the device. So anything that is polarity sensitive, the circuit diagram will show you which side is positive, which is negative. So just be aware of that when you're building any kit like this, or installing polarity critical components like capacitors and battery holders and all the rest of it. Okay, so what I'm going to do is I'm going to carry on finishing the build of, well, I'm not finishing the build, but actually the installation of these resistors. And once that's done, we'll come back and we'll see what that looks like. Thought I'd take a risk actually and show you how I install a couple of resistors. The next two resistors I've got to install are R31 and R32. And you can see on my sheet here, where are we? Yeah, there. So R31 and R32, 1K resistors, and they are marked 102. So if I get my tweezers and I'll grab one of these little guys. Hopefully you'll be able to see that. I don't know if that's going to, yeah, there we go, 10. So you can see there 102, so I know that's the right resistor. And these things are apocalyptically tiny, absolutely ridiculously tiny. So now I need to do is to find where on the board resistor 31 and 32 sits. So the next thing to do is to have a look around. Doesn't seem to be any logic to, I'm sure there is a logic to the numbering system of the capacitors. There they are, so there we go. R31 and R32, and if I put the sheet that way, I can see that they're located there. And if I get the board itself, I can see that those two resistor slots are going to be these two here. So the first thing I'm going to do is, knowing that these are the two pads that I need to install those two resistors on, I'm going to get my, I'll probably just do one resistor just to show you, but what I'm going to do is just on that pad there where you can see the tip of my soldering iron, I'm going to first of all see if I can get a bit more light on the subject, if that helps a little bit. Hopefully it does. And what I'm going to do is just put a dab of solder. I don't know if you can see this. I think you might be able to. I can't zoom any more than that at the moment. It's not really designed for that. There you go. I've got probably too little solder on there, but you can see there's a blob of solder on there. Wipe the soldering iron clean, and then comes the tricky bit, which is grabbing the component in question with the tweezers. Yep, that's the right way up. Next thing to do, grab the soldering iron, melt down the solder, and then just offer up the component to the solder like that. I usually have a quick look under a magnifying glass. I can see that is, well, from my point of view, let's get the light on it. From my point of view, that is okay. That will be flat. You can see on the edge there. And all I need to do now is bring the soldering iron round and solder the other side of the device. So it's a resistor in this case. Put it there, so hopefully you can see what I'm up to. So just put the iron there, bump, bit blob, bang, done. The solder will just comb its way onto the end of the component. So let's have a look at that, see what that looks like. It's that one there. And I think that's okay. I'm not sure I've got enough solder on there. Actually, I might have just done that a little bit too quickly. Yeah, let's just do that again. I think I was just trying to be a little bit too fast with the solder there. So I'd normally got the magnifying glass out for this. There we go. Let's try that. So I'm no expert at soldering. I'm not an electronics expert. I'm just a hobbyist. But the most important thing to check for there is there any bridging across the components at all? I think the answer to that is no. And you can see the solder on that side and on that side, and the number of the capacitor resistor is legible, which generally also mean that there's no bridging going on, and that's looking okay. So I've got another one to do down there, and that's how I do the resistors. So I'm going to finish off doing the rest of the resistors, and we'll be back with you a bit later. Okay, so I've now finished installing all of the resistors on the board. I did notice that some of the resistor names or numbers are not quite the same as they are on the listing. So, for example, I think R15 was like 3301 on the actual device. So the thing to do is, where the numbers perfectly match on the devices, do those first, and where they don't quite match, whatever you've got left over, it should be obvious which resistor slots they go in. So it's just a point of order. A couple of other things is that I haven't quite worked this out yet, but you can see here resistor 8. Now that's the 2K variable resistor. You can see it's located near jumper 3, but if you actually look at the board itself, there's the 2K variable resistor, but it's actually jumper 2. So I don't quite know why that is, but there you go. I dare say all of that will come out in the wash, hopefully. So the next thing to do is to have a look at some of these other SMD components, like T1, their transistor 1 that lives somewhere. I haven't quite worked out yet. I think it's probably the other side of the board. But so what I'm going to do is I'm going to start doing the rest of the small components, like these diodes, a couple of diodes here, and to say that transistor. What else do we have here? T3 to T6. Again, more transistors, I guess. And so these little ones, I'm going to leave the LEDs till later. But what else we got here? An IC6. Not sure what that is. Again, the electronics experts amongst you will be able to work out what these bits are, and so on and so forth. Some more transistors, I think. So I'm going to start getting those in, and once they're done, I'll come back to you. Okay, bit of an update. I've got most of the, I've got all the resistors in. Also added in some of the transistors. You can see here along there. It's an IC. All transistors there. I've got it upside down, haven't I? That's the IC. I think. Yep. And as I say, all the transistors here. Again, they're a bit wonky. It's all done with tweezers, but generally speaking, they have all fitted in reasonably easily. As I say, this surface mount stuff, you've really got to have a steady hand, and these parts are incredibly tiny. You can see there. I'm not sure if that's I think that's a capacitor, and you see I haven't quite got it lined up with the pads, but it's connected to the pads, and at the end of the day, that's what matters. So it's not very tidy, but hopefully it will work but it really does take a very, very steady hand to get these things put in neatly. See, there's another component there. Again, another capacitor which is not quite straight, but it's connected correctly, and I have checked for any bridges across the 2 connections, or 3 connections in the case of these guys, and it's all clear. So onwards, what have we got left? We have got a couple of diodes to go in. These, which are surface mount ICs, apart from one socketed IC, they're going to be a nightmare, but we'll look at putting those in when I get round to those. We've still got some LEDs and associated resistors, I think we have in there, and what I'd call the hardware bits and pieces here. So I'm going to have a look through. I want to do some of the smaller things like the diodes. I think getting the small components out of the way first, the diodes and also the ICs and probably the LEDs, pretty critical to get those out of the way, because they're the ones that require the most concentration. Make sure we don't screw up on those. So there we go. That's where I am with it at the moment, and I'll populate a few more of the components and come back to you very shortly. Okay, a bit of an update. We moved along. I've now populated a lot more of the components, the ICs, as you can see there. ICs a little bit tricky to do, but very simply what I do is I'll just apply a blob of solder to, say, one of the outside pins, like that, attach the IC to that pin, make sure it's all squared up, and then a quick blob of solder and heat to each of the other pins, and they go on very nicely and neatly. So I'll bring that a bit closer so you can see a bit of the soldering. Nothing to be amazingly proud of, but there's no, you can see there's a bit of a solder blob there that needs sorting out. I put the socket in for that last IC, but not populated the IC just yet. I'll go back the other side. You can have a good look at where everything goes. Up to this point, at any rate. One of the things I do is after each component is installed, certainly the small components, at any rate, is I use this little jeweler's loop. Got 2 magnifications here. One of them's 30 times and one's 60 times. It's probably too much really, but I can really see whether there are any problems with the solder joints using this, and it also has the benefit of illuminating. There's 2 LEDs there, one for each lens, and then the other side, and so on. Very useful to just check that your solder joints are in good condition, that there's no bridges or any other damage that may have occurred during the process. So still quite a few things to do. There's this IC to go into that socket. I should do that in a moment. And then there's all the hardware-y bits and pieces. These are the ones that are worrying me. These are the LEDs, and they are a swine to solder in because they are so tiny. But the principle will be exactly the same. Blob of solder on one side, get the LED pushed into that blob of solder as it's being heated up. That grabs it, and then you just solder the other side. Easy said than done, I guess. So that's where we are at the moment. So there's that IC, LEDs, still a bunch of hardware to go in, and capacitors. I'll probably get the capacitors in next, the electrolytics. And like I said before, polarity will be the long pin, that one in this case, to go in there. I'm not sure if this is the right capacitor for that particular location, but the principle's the same. So the long pin into the positive, short pin into the negative. Of course, when installing the ICs, it's important to notice the polarity on those, because you'll see that if we see on this IC, you see on the PCB, if it will focus for me. There we go. There's a little black dot on the PCB, and you'll see that there's a dot on the IC, and as long as those two are together, then all is well. On this one, you'll see just underneath on the screen printing that there's a little U-shaped notch, and again, you just need to get the dot at that end of the screen printing, and you're fine. Same principle here. There's actually a notch in this particular IC. Dot, 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 and so on. Great. Well, hope this damn thing works. We shall see. I'll be back with you later. Okay, well, it's day 2 on this build, and we're pretty much ready to start thinking about the Nixie tubes themselves and also the LEDs. But before we do that, there are some instructions to actually test whether or not the device is working properly at this particular stage. So after having built the main board, it tells you to test the voltages on a couple of the capacitors. So first we solder the elements. I presume they mean there's obviously some parts or points lost in translation here. So resistors, capacitors, So down here, so basically that's basically saying install everything in this particular order. I didn't necessarily follow that, but certainly installing resistors and capacitors first is a good idea, and the transistors, this smaller stuff. So, okay, adjustment is reduced to checking the operation of the down converter. I presume what they mean by down converter is... you can see on here you've got a couple of inductors, which, again, I'm no electronics expert, but I guess it's to test the voltages that they are either reducing or amplifying. And I would have thought they were amplifying quite a bit as well. So check the voltage at the capacitor C10. It should be 5 volts plus or minus 0.2, is that microvolts? After that, we close jumper JP2. It supplies power to the boost converter. Again, is boost converter. I'm guessing that probably means the inductor. Check the voltage at the capacitor C11. Should be at least 65 to 85 volts. Variable resistor R8. Set the value of about 160 volts. If everything works, we short circuit jumper JP1. It supplies 5 volts power to logic chips, and jumper JP3, it supplies high voltage to the block of anode keys. Okay, so again, a few things lost in translation, certainly with me here. Now, I have to say I've actually done this already because... which is a bit selfish of me, because if it was going to go up in smoke, I'm sure you would have loved to have seen that, but fortunately it didn't. But what I want to do is try and show you some of the jumpers that it's talking about. So you've got JP3 there, which I've closed, basically bridged. JP2, again bridged. And I think the other jumper's on the other side, if I recollect, yeah. There you go, JP1, jumper 1. So basically what you're doing is you're measuring the voltages across that capacitor, which is capacitor 11, and also that capacitor, which is capacitor 10. So just to show you what it is, I'll just put my cheap, nasty, complete rubbish tester on. Yeah, just it's probably a bit unfair of the meter. Actually, it's not that bad. Good enough for somebody like me who doesn't know what he's doing. So there we go. We have got. Now I'm just going to check the polarity. So minus is going to be at the bottom. So that would be capacitor 10. So I suppose it would be a good idea to put some voltage into it. I'll come on to that again in a minute. So there we go. I powered it on. We now have. I should have thought about this beforehand. There we go. Okay, so we have power going to the unit, and with a bit of luck, I think this one, if I'm right, is showing. We'll need to show the 5 volts. Could be wrong, but anyway, we're on DC, and we have got 5 volts, 5.13 volts on that capacitor. So that's what you're looking for there. And on the other capacitor, it's more like 160 volts. So on that one, just make sure I've got the right pins, and minus is the other way round. So that capacitor, so, and let's test the voltage here. And that is all over the place. There we go. 159.4 volts, and we're looking for 160. You know what? I'm going to stick with that. Now, if you needed to adjust that voltage, the way to do it, let me just power that off for a second. The way to do it is using resistor 8, which is that little trimming pot there. Now, interestingly enough, and I don't know why this is, it's just obviously the design of the circuit board, but basically the resistor 8 can either be located there, where you can see it on this particular build of mine, or it can actually go on the other side of the board, right there. Why it's got 2 options, I don't know, but there it is. I'm guessing it would be better to put it there, because if you do have to trim it, it is pretty much surrounded by components in that location, so it would be easier to get at it there. But I guess that's up to you at the end of the day, but that's just a quirky little thing about this particular kit. Okay, so the tests seem to pass. We're okay with the correct voltages on both of those 2 capacitors. The next thing to do is to start looking at the next set of diagrams here. I almost lost that little Nixie tube there, which is for later. Yeah, so I'm going to sit down and study this and work out where everything goes. It looks like up here we've got the diodes, the LEDs, and I believe they're effectively a diode symbol as well. And here as well, locations there. And we also got a bunch of resistors to go in somewhere as well, which I haven't quite worked out. And that will be the components in this little bag. There's actually something written on it. It says backlight. Okay, which is exactly correct. It is the backlight for the Nixies. It just gives it a a glow. Now you can actually, I think, choose different colours. Traditionally it seems that blue goes down quite well with backlighting Nixies, and I can't remember whether I chose blue or a different colour. It was that long ago that I ordered it, and I'm not so sure. And there we go. Those are the LEDs, tiny beasts, and I think I'm correct in saying that the green stripe that you can see represents the negative side of the LED. And then here we have a bunch of resistors. What's the number on them? Oh, damned if I can read. Hang on. My aging eyesight, 1301, I think. I don't know. I'll have to get the magnifying glass out. But anyway, I'm guessing there is one of these resistors for each LED. That would make sense to me. Whether that's true or not, yet to find out. So I'm going to have to suss out how all of that goes, and once I've got closer to doing that and perhaps starting to assemble a few of the LEDs and resistors, I'll get back to you. Cheers. Just before I carry on with the build, we just have a look at the Nixie board, and as I showed you earlier on, we've got 8 LEDs, and we have, I haven't lost them, 8 corresponding resistors, and it wasn't immediately obvious where they should go on the board, but logically the board with this pattern on it is where you would put the Nixie tubes. The Nixie tubes would be here facing you, so this would be the display side, which means that if the Nixies go this side, then these here are the locations of the LEDs. And if you can see, if I bring it a lot closer, there is a little black line shown on these against each location for the LEDs. That would be the negative side of the LED, the cathode. Therefore, it logically follows that on the underside, which this would now be, is where you would put the resistors. So 1, 2, 3, 4, 5, 6, 7, 8 resistors, and the same number in similar locations on the other side for the LEDs. If you look at the LEDs closely here, you can see that there is a green bar, and the green bar signifies the cathode. So the green bar would go next to or go this side where the black bar, that black marking, is on the location of where the LEDs would go. So that is what I'm going to do next to get those LEDs in. The other thing I haven't done yet is to install the connectors which will bring these two components together. So you'll have it'll be something like, it'll be that way. So these two will plug together courtesy of these components. So what I'm thinking is that it will be like that, and where's the other one? There we go. Like that. Actually, I'm not too sure whether I should do it the other way and have these blocks on the main board and these smaller pins on the Nixie board. I haven't decided. I think it actually would probably be more sensible to do it like that. I don't suppose there's a right way or a wrong way, but I think I'll do it that way. Okay, so let's get those on. Let's get the LEDs and the resistors on, and we'll go from there. Well, things have moved on a pace since the last section of this video. A couple of days have passed, or certainly a day or so. And the reason for that is I had a little bit of a problem. And the problem is that I finished the kit, as you can see. Show you all the final. Let's get some light on this. The final assembly of the Nixie board itself, and in there you can see, and well, you may not be able to see, but underneath the Nixie tubes themselves are the tiny little LEDs which we saw installed before. And one of the problems is I damaged one of the LEDs, and I couldn't remember what colour the LEDs were, so I stole an LED from another kit that I was constructing, and put that in there in place of it. So a bit of a cock up on my part there, broke one of the LEDs. Luckily I had a spare, although all is not entirely well as far as that is concerned. So I put everything together, and as you can see I've installed the connectors like that on the main board. Okay, the male part of the connectors there on the Nixie board, and the two just plug together like this, and there we go, and that makes for a very nice neat assembly, and that is the finished kit. So when I powered this up, and incidentally, if you remember the power supply that it came with, there's the connector that I've soldered on. There's only 2 wires. What you do need to do is make sure that the positive is the center pin and the negative is the outer pin. Okay, so that's fine. And powered it up, and the problem is that the clock came on fine, came off with a 0, nothing on that tube, 0 0. The Nixie dot, as he calls it, in the middle there was flashing once a second, which showed the clock working, so no problem there. When I went to set it, you got the 2 switches here. That's mode and that's set. So you select which mode and then you set it with that one. So you press mode and then you set the hours, mode, then the minutes, and so on. But that wasn't working. Nothing was happening. I could click these all day long and absolutely nothing was happening. When you click mode, what should happen is that the Nixie dot goes solid, indicating that you're now in the mode selection, but that wasn't happening at all. So I ended up emailing the seller, and I sent him photographs of the main board, and he came back almost immediately showing that I had made an error, which apparently others have been making as well, and that is that these 2 resistors, which are, find them on the circuit diagram, where are we? Yeah, these 2 here, R32 and R31, I had them the wrong way round. So instead of having them this way, which is the way you should be, vertically, I had them horizontally. Okay, and because of that, these buttons wouldn't work. So as you can see, I've made an awful job of it, but I managed to desolder them, flip them around the correct way like that, and the whole thing works perfectly. So that was cock up number 1, which the seller very swiftly diagnosed for me, and that was brilliant. So if you're going to buy one of these kits, you can be sure that the seller will help you out, which is very good. And when I say help me out, when I emailed him photographs of the board, he came back within minutes to explain what the error was, and minutes later I'd fixed it, emailed him back, thumbs up, thanks very much. So that's perfect service, brilliant. So that's good. So that was cock up number 1, which the seller fixed for me, or diagnosed for me. Cock up number 2 was the fact that I broke one of the LEDs, but I put another LED in there from another kit. So here we go. This is what you should get when you first, well, not when you first power it up, but this is what it looks like. And there she is. Now you'll probably see the LEDs, the Nixies are flashing away there. That's because of the frame rate on the video. It's not, Nixies are not actually flashing like that in real life. So there you go. There's the time, almost 6:30. It will change. Let me switch the lights off, and it will show it a little bit better. In fact, give me a second. Right, shove the light down a bit more, keep the sun out. There we go, you can see it much better now. That's probably a bit overexposed now, isn't it? That's probably a bit too bright. Okay, never mind, but there we go. Very nice, very pretty. But can you see the obvious mistake? You probably can't actually. Let me open that curtain again because it was better with it open than closed. There you go, not quite so overexposed. But you can probably see that these three tubes are green, are backlit with green LEDs, and this one is backlit with a blue LED at the bottom and a green one at the top, because each tube has 2 LEDs lighting it up, and the blue one is the replacement for the one that I broke, but I couldn't remember what colours the LEDs were, so it's got a blue one there. And do you know what? I'm not going to bother desoldering that particular that particular tube just to put in a green LED, because I'm not even sure I've got a green LED. But it works with the blue one, and I think it looks rather nice. In fact, if I do anything, I'll be rather tempted to unsolder these three and stick a blue one in, because I think that looks cool. And then that's me. At any rate, there you go. It's cycling through the date. That's 13th of September. Then it comes back to the time again, 1830. You can also configure the year. You can configure it to be 12 or 24 hours. And that's a nice little kit. The only thing I haven't sussed out yet is whether there is a case that you can buy for it, or whether I'm going to have to make one myself out of, I don't know, wood. I don't know, perhaps you could even, although it's a rather large, convert the wooden box that has the protective packaging for the Nixie tubes. Perhaps even convert the wooden box that it came in and use that as a display case, although compared to the size of the clock itself, it's a little on the large side, but I don't know, it might work. So that's an option. You could use the case as a use the box that it came in as a case. Just a thought, but there you go. Really pleased with the outcome of that, despite my errors. So thanks to the seller. If you go onto Etsy, ETSY, you'll find this particular clock and others that he does. I would certainly recommend it, mainly because I think the components are of good quality. The instructions are a bit lacking, but you know, a little bit of time and patience, and you'll suss out what everything needs to do. Obviously, I made a mistake, but that was a bit of a schoolboy error. And but perhaps the most important thing is that the support from the seller was absolutely excellent. And to me, that's a win. When the seller's really trying to help you out, and this guy was absolutely fantastic, so brilliant. So there you go, that's the Nixie clock using IN-12 tubes from Etsy. Hope you've enjoyed this this video. I know it's gone on a bit long, but there you go, I've enjoyed making it and I've enjoyed sharing it with you. So all the best to everybody, and thanks very much. That's that. Cheers for now.